आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
We bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is designed and devised by Dr. R. Sridhar and assisted by Ashish Tiwari, produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
We are immensely happy to receive a conversation from Dr. Basudeb Maji in this podcast. He will be introducing himself and will also be sharing his academic journey with us.
Hello everyone, I am Basudeb Maji, an assistant professor in the Department of Biological Science at Bose Institute. I received my PhD from IISc Bangalore and worked at Harvard Medical School and MIT for my postdoctoral work. My lab here at Bose Institute focuses on chemogenetic research. We look into both chemical and genetic aspects in fighting diseases.
Now, Dr. Maji will be sharing with us his area of research in brief.
While medicines have become an integral part of our lives, either to enhance function or to sustain in an unfair environment, developing new medicines still remain extremely challenging. The recent revolution in AI might be able to fast-track the design of drug molecules, but that's not enough. Medicine development has several other components like developing specificity, stability, bioavailability, and ensuring efficient delivery, and many other aspects. Our lab is working on some of these frontiers of high-throughput and fast-track drug development. So in a conventional method, drug molecules are systematically designed and chemically synthesized in laboratories and then tested for their activities. But it's an extremely time-consuming and laborious method. For example, a typical drug molecule development takes almost a month and then a couple of more months for testing its efficacy and activity and overall validation. After such rigorous exercise, we identify the lead candidates, which are then customized for improvement. There are ways to expedite these processes and to identify lead candidates. For example, at Broad Institute, where I worked for 5 years, they have a library of high-throughput screening. They have a library of 100,000 compounds, which you can directly test and screen to identify lead molecules. However, this kind of facility requires enormous resources for functioning. Moreover, such screening is done in a non-biological environment. Our lab is working on two main avenues for developing novel drug molecules, utilizing minimum resources. Our method that we follow are mainly two kinds. One is developing PROTAC kind of drug molecules. Then other one is synthetic biology based novel drug development.
Dr. Basudeb Maji now explains this subject in details.
Now to explain what we do in a little deeper way, I'll draw an analogy. For example, in our daily lives, we all generate lots of wastes. These wastes are either leftover or expired materials, and we have proper mechanism to take care of them. Accumulation of these waste will make our surrounding unhealthy and toxic, and we cannot survive. Similarly, our body at the cellular level has machinery to take care of these cellular wastes. For example, a protein. A protein is crucial and vital in cellular function and physiological role. The same protein becomes non-functional and toxic after certain time and become burden for cells and overall a being. To remove such burden, cells have various shredding machinery inside the cell that chop off these non-functional and toxic protein and transform them into basic amino acid building blocks for new synthesis of protein. Now, if you think of a disease, there are some notorious proteins that play an adverse role in promoting the disease, for example, like cancer or diabetes. We develop molecules that can drag these toxic and non-functional proteins to this cellular shredder and break them and remove them. This method is known as PROTAC or proteolytic targeting chimera. The beauty of this method is it is built based on existing molecule, so the overall development of the drug candidates are fast track and inexpensive. The other method that we use is synthetic biology based drug discovery, where we combine genetics and chemistry. Instead of synthesizing them in chemical lab, we rather engineer microbes, for example bacteria, for developing these drug candidates. Bacteria have an amazing ability to make molecules, both rapidly and economically. We utilize this virtue. We genetically engineer bacteria so that they can make our drug molecule or drug candidates as per our design. We program them in such a way they can not only make these molecules but also check their activities at the same time and provide you with the best drug candidates. We have developed a system that can make millions of drug candidates within few hours and develop lead molecules. Currently, we are developing molecules inside bacteria that can effectively kill notorious pathogenic bacteria to deal with microbial resistance or superbug. And we all know the adverse effect in global effect, I'll say rather, of the superbugs or antimicrobial resistance and how we all are suffering in our daily life because of the superbugs. We believe that such high throughput, inexpensive and fast track development of drug candidates will help to deal with superbugs and serve the society.
Dr. Maji now speaks on the future of drug development in India and abroad.
The future of drug development will be driven by AI-powered drug design. Also, synthetic biology, personalized medicine, nanotechnology-based drug delivery, and advances in genome engineering methods, for example, CRISPR, will help in developing promising gene therapy.
Dr. Maji now speaks on the huge opportunity of drug development to collaborate with the industry.
There are huge possibilities in India, and our lab is actively working on some of these frontiers with the help of DST and other funding agencies from Government of India. Potent drug development and availability is extremely important for humanity to survive and sustain. Thus, industrial importance of novel drug candidates and lead molecules are always very important and priority. In India, drug markets, basically they focus on natural product based molecules where we already identify molecules from natural sources and then try to utilize them for different purposes. Sometimes we modify them to tackle diseases as well. But developing novel molecules or novel drug candidates is a tedious process. And in chemistry based development, that takes extremely long time. So in India, unfortunately, do not have efficient strategies or methods available for fast track drug development. Thus, this is very important that academia and industry makes collaboration and takes care of this particular issue. The methods that we are developing in the lab can take care of fast track drug molecule or drug candidate development, but that's not the end. Once we identify the lead molecule, then there has to be various modifications to ensure efficient PKPD and other bioavailability and delivery efficiency. So that needs to be done in collaboration with industry. So we have huge opportunities to collaborate with industry, and that will complete the circle in drug development, and partnering with industry will definitely help in developing novel drug molecules in India.
It would be best to hear from Dr. Maji regarding the collaborators and contemporaries.
Now, drug development in India mainly focuses on natural product based discovery. Currently, what we are focusing on, how to develop unnatural drug candidates or synthetic drug candidates which can be designed within engineered microbes. Now, that doesn't involve synthetic chemistry, and also it is fast track and high throughput. So, high throughput drug discovery, if you think about in India, is very limited. There are opportunities, but we haven't advanced in these areas too much. So, in India, drug development using non-natural sources or non-natural molecules are limited, and in global market, the avenues or the methods that are available are too expensive. So, for India, it will be very difficult to utilize and access those avenues that are available at the global platform. We believe in India, if we can develop our own indigenous method for developing drug molecule using minimum resources, that will be helpful for our society, and we can also strengthen our drug development sector.
We are extremely thankful to Dr. Basudeb Maji for being with us and for sharing the information of his valuable research work. Thank you so much.